Hey everyone, Chang here and welcome to my channel. For today's video, we're just gonna have a little fun. Now, in previous video, I mentioned that my favorite type of math problems are usually the puzzle or competition type of problem. Now, the reason for that is usually they don't require some super high-tech computer or calculator to do your calculations, right? That means that you can actually reason your way through it, you can rationalize, and you could probably find some shortcut or neat tricks to make your life with the problem a lot easier. So, I just went and found 3 random problems, and let's just go over it and see what we can enjoy about it. Our first one right here, you are given 235 foot of fence and a 5-foot gate. What is the largest rectangular area that you can fence off? Now, if you are familiar with these type of problems, either from class, from textbooks, from, I don't know, tutoring session, wherever you've seen it before, these are known as optimization problems. Now, there are easy ones where you can just basically find formulas or equations and work with them. And there are the more difficult ones where you actually have to use calculus to solve. Now, here's the thing. This one, as I mentioned, is a puzzle type problem. It's a competition type problem. That means it's not going to require any heavy computation. So that means probably calculus is out of the picture. Or at least it's going to be super basic calculus. From here, we can at least sort of assume it's not going to involve calculus because it's not nearly as complicated as it seems, as long as we break it down and understand what it's asking. So, what is the largest rectangular area that you can fence off? That's the key right here, rectangular area. Rectangular, right? That means more complicated shapes like circle, octagon, pentagon, you know, crazy star, whatever, right? Those are all out of the picture. This is a rectangle. Now, remember, rectangle is, well, basically rectangle in terms of opposite sides are always equal. And the 4 corners are all 90 degrees. Now, rectangles are rectangles, but square also matches that definition, right? Square has opposite sides are equal, and all 4 corners are 90 degrees. So square is actually a special type of rectangle. Now, the reason I included this is because, well, guess what? We're just trying to find the largest rectangular area. So we can't rule that out. We're just finding all types of rectangle. That might include a square. So let's see what else we got. Well, we are given 235 foot of fence and a 5-foot gate. Now, I was thinking about why they would separate those two, and I couldn't find a good reason why. At first, I thought it could be if we do something like crazy, like for example, not the best way, but we fence like a super thin but super long kind of rectangle. Yeah, if we put 1 and 1 right here, and we look at it, well, we can't put the gate here because it's just going to be 1 foot. So the gate has to be on one of the 2 sides. But I mean, that doesn't really matter. So if that's the case, we can just combine these two and figure out that the total amount of, I guess you could say, foot in terms of creating a fence is just 235 plus 5, which is 240. 240 feet. Okay. Well, if that's the case, and we used 2 already, 1 and 1, that means we have 238 left. Well, 238, remember, these 2 sides must be equal, so we actually have to divide by 2. So 238, we divide by 2 is just going to be 119 and 119, right? That's 238. All right, and then if that's the case and we multiply them, well, the area for this is going to be 119 times 1. 119. Okay, cool. Well, that's probably not the best way. What if we widen this part a little? Instead of 1, let's say 2. Well, that means you're technically taking 1 from each, right? So what is that? It's going to be 118 and 118. Okay, that means if we multiply those two, what is that? That's 236. Okay, that's good. That's definitely a bigger area than that. And then we can keep going. Eventually, if we just wanted to, we're going to keep going with 3 and then 4 and 5. And then eventually we're going to get to the point where it's just going to be super long. And then we're going to have a 2 on this side and 118. And then we can even go all the way to 1 on this side and 119. So hopefully with this, we can sort of infer a pattern. It's going to get bigger and bigger and bigger and bigger. And eventually, it's probably going to hit some point of what we call the largest, the biggest, right? And then afterwards, it's probably going to shrink again because it's just going to go the opposite. It's almost like symmetrical, right? As eventually, it just ends up becoming like this is flipped. And since this is flipped, that means this is going to be 236 in terms of area, and this is going to be 119 in terms of area. So it's going to be small. It gets bigger and bigger, bigger until it hits like that midpoint. So it's just going to, and you guys probably have seen this before, it's going to look something like this. It's small and it gets bigger, bigger, bigger. Hit a midpoint where that's probably the highest. Then it's going to go right back down. Something like that, right? No, so if that's the case, that means the halfway point is probably the best bet. So if we're going to go with that, I'm going to erase some of these, and then we're going to test out the halfway point. Well, the halfway point is technically just getting this guy. And I wouldn't say cut it in half because there's 4 sides, so you're just going to cut it equally in 4 parts. So if we have 240 and we cut it into 4s, 240, and we divide it by 4 or cut it into 4, that's 60. That means the side is going to be 60 each. 60, 60, 60, 60. All right, cool. Well, that's legal because technically that's a square and a square is a rectangle. So 60 times 60 is 3,600. Wow, that's tremendously bigger than any of these guys. But we're not sure if that is exactly the one we want. So let's just try a different one. So let's erase this part, and then I'm going to change it up a little bit. And then if it gets any bigger, then yeah, that's not it. If it gets smaller, then we're getting somewhere. So, for example, instead of 60, 60 on both sides, let's say 61, 61, 59, and then 59. And I can't do this in my head. Let's do right here, 61 times 59. And you know the standard multiplication is 9. And then what's that? That's 54, 0, 5, and then 30. And then right here is going to be 35, 9, 9. Oh, and that's hard to see. Let me just box it so you can see it. 3599. That's not the answer. But if that's the case, since we alter it very slightly just by adding 1, and we got to take away 1 just to guarantee that we still have 240 feet, right? The area is actually 3,599 compared to 3,600. That means even if we switch it the other way, this one becomes 61, this one becomes 59, the area is still going to be 3,599. So that is our optimized or our largest rectangular angle or area. So from this, that's just basic reasoning out. We start off with the most crazy one, this super thin and super long one, and we start realizing it's going up, right? The area is going up. And eventually we realize that as we start compressing and stretching it, it just basically looked like we just flipped the rectangle around, and then the area is still the same. So we found the midpoint, and there it is. Simple reasoning, didn't really have to have a formula or anything. We just, by logical deduction, realized that it gets bigger, then gets smaller, so probably the halfway point is where it's going to be the biggest. Now, for this next problem, have you ever had those situations where you hear someone talking, or maybe your friend, or just the news in general, and you have that very nervous kind of laughter where like, oh, it might apply to me? Yeah, that's sort of the feeling I got when I was reading this problem. Now, I'm really hoping that this was just some person who wrote this problem just had a funny sense of humor. If not, I better go get tested. After 2 years of teaching, 180 teachers were tested for health problems. 80 had heart conditions, 60 had diabetes, and 30 had both. How many had neither? So basically, out of the 2 possible health conditions in terms of heart condition and diabetes, how many of them have none of those? So, with something like this, it can be a bit overwhelming with so many different numbers. And the core, or the I guess you could say the catalyst of this problem that makes it confusing is the fact that there are some that have both. That means these 2 numbers, the one that had heart condition and have diabetes, are not entirely accurate. They're not I guess you could say exclusive, because there are going to be some that are counted in both of them because they have both. So how do we organize something like this? Well, this one, interestingly enough, a picture helps a lot more. So hopefully you guys seen this before, probably in elementary or middle school. This is called a Venn diagram, right? Or, you know, glasses, whatever you want to call it, because I'm terrible at drawing. But basically we have one side, the other side, and whatever's in the middle is what's shared. That helps us tremendously if we say this is heart and this is diabetes, or high definition. So in that case, let's just look at how many had both first. Well, 30 had both, so good. At least we know right here, we're just gonna say is 30. Cool. Now we can actually look at each side and then sort of reason our way through this one. Well, let's look at heart condition. Heart condition, there's 80 total. Out of the 80, we already know that 30 has both. So we don't want to recount them because we already count them in the, I guess, the middle section, right? So technically it's gonna be 80 minus 30, or, ooh, bad penmanship, or 50. Cool. Same reasoning on this side. Diabetes, 60 of them have it, but we already have 30 of them that have both conditions. So in that case, rather than just put the whole 60, we have 60 minus 30, which gives us 30. Okay, cool. So that gives us three numbers. That means that these three numbers added together is all the teachers that have one or the other or both. So 50 plus 30 plus 30. That's simple. 50 plus 30 plus 30 is equal to 110. Now, 110 is the total amount of teachers who have problems, which is actually a lot out of 180. So we're just going to have our total, 180, and we're going to subtract the number of teachers that have problems, and that will give us 70. So a total of 70 teachers are actually still healthy, at least compared to these two conditions. Now, this last problem I included because I thought it was just hilarious. It's not complicated in any way. It's not like, oh my god, I need this super crazy trick to solve it. I just think that, let's just say it doesn't age very well. This is a problem that's, I think it was in like the 1960s or 1970s. And the reason I think it's just hilarious is because they used the star symbol or the asteroid or whatever you want to call it. Now, in our more modern day computer, normally, or even in calculators, right, the computerized calculator or sometimes the phone app, they would use this symbol as multiplication. But that's not necessarily the case, I guess, in the 1960s or 70s. I can't remember exactly the year. But maybe because computers aren't like super common then, don't quote me on that, but I guess they just assume that as long as we put a symbol on it and we tell you what is defined, then you can solve it easily, which that means anyone in those times who encountered a problem like this would probably have no problem. But in our generation, and I'm not that old, but I mean, even I know like that's immediately to me was like multiplication. That's going to cause a lot of problem, or very easy for us to make mistakes, because I mean, if we look at this, especially if we just skim and we don't read, what is 2 asterisk 3 or 2 star 3? Immediately we think, okay, well 2 times 3 is 6. We are done. That's it, right? There's no questions asked. But here's the thing about math is the symbol in between 2 variables or 2 numbers is something we either define, and if not, it's already a sort of predefined thing. So if we put this symbol right here, we immediately know, because we grew up with this basic condition, that that's a plus sign. That symbol means that whatever the 2 numbers are in the left and right hand side, we're adding them together, right? Finding, well, counting them and adding them. And then of course the same is with that, the same is with that. Let me draw it better. And the same is with that. But eventually you start seeing crazy symbols like this, and then you're trying to figure out what it is. And then sometimes you have to actually look in terms of the context of the problem or the textbook and what they mean by that. This, they were using as a similar regard. If this top sentence didn't exist, and we only saw this, and ignoring the fact that we immediately are conditioned to think this is multiplication because of computers, we wouldn't know what to do with it. Well, luckily up here it tells us exactly what it is. A star B is defined as 4 times A minus A to the power of B. So if we see this right here, 2 star 3, as tempting as it is to do multiplication, that's not what we're doing. We're just going to plug this. This is A, this is B, and then we're going to solve it using this. So it's going to be 4 times 2 minus, and it's going to be 2 again because that's still our A, and B is 3. So 4 times 2 is 8, minus, and 2 to the third power is just 2 times 2 times 2, which is 8 as well. So 8 minus 8 is 0. And just like that, that is the actual answer for this problem. So once again, I just thought it was hilarious. All right, so with that, at least that's just 3 more puzzle competition type of problem that you guys can just have fun with. I mean, that's the lovely thing about these kind of problems. It's not like, all right, I know exactly what subject or what topic it's going to cover, because when you're working with problems in textbook or tests, you immediately know that's probably the subject or the topic, because guess what? Your instructor went over it, or guess what? Your textbook mentioned it in the previous chapter or previous section. Whereas in these kind of problems, it's like it always keeps you guessing, and that's half the fun, right? You're not sure exactly what to do, so the concept of being able to reason it out, try to just paint a mental picture, just go with it, chip away at it, and see what happens is what makes it so enjoyable. Anyways, thank you for watching. See you in the next video.